Hello everyone. Can you hear me? Okay, I guess you can hear me now. Let me just bring chat. Okay. Hi. Great. Thank you. How about you? I mean, what are you? What? How was the contest for you guys? Okay, go through the stream. Go through the question and your idea before starting the stream. Okay, if you want, I can do that. Sure. Ah, my voice is low. Really? Thank you. It wasn't a very good contest for me because yeah, I was too slow. Unfortunately, I need to. I'm still a bit rusty. I have to train more, and we will do that for sure for NAC. So, let me first, as you suggested, first I tell you about the main ideas of each problem, and then we will solve them one by one. Okay. I hope that works. Well, the first problem is just some math. In the first problem, my approach was greedy, and I was trying to, as much as I had at least two by two cells, I put those two in a 3 by 5, and those 1 by 1s will be the rest of them. I mean, the rest of the 7 cells will be 1 by 1. So I try to put as much as 2 by 2s as possible first, and then I do the rest. This was the main approach for A. I will tell you the solution in more detail, but let's for now just have a summary for all the problems. For the second problem, for this decoding problem, in this problem, decoding and encoding are both the same procedure. So the same thing we can do is that we can just save all the characters and just sort them lexicographically and just reverse them. I mean, find what is exactly the reverse of this one, what is the match for this one, and change these two. For the problem C, okay, for problem C, I use map, and I just save that how many times I have, for example, these three elements in a row, how many times I have these two elements in a row, how many times I have these two elements in a row. So I save all of these, AI and AI plus 1, AI and AI plus 2, AI plus 1 and AI plus 2. MP1 is for the first two occurrences, so the first one is AI, the second one is AI plus 1, the third one is question mark, for example. MP2 is for first one, and the last one, the middle one, is question mark. MP3 is for the second one, and third one, the first one is question mark. And this is for all three. And I use map in order to solve this. This is the general idea for problem C. For problem D, the general idea was that first, the north and I mean, if we count that, assume that we have only one robot, and we are going through this. At the end, the coordinates should be even. If one of the coordinates is odd, then the answer is definitely no, because anyway, I mean, if in x axis or in y axis, I mean, the overall of all the moves is not in an even position, anyway, that we split these moves into two, for example, robots or rover and helicopter, then they will not end up at the same place. So it should be even, and if it is even, I should just divide both of them by 2 and try to move each one of them to that place. And I use a greedy approach for that. There's only one special case that we have only two characters with two moves, and they both and at the end we go at the same time, and that is when the fact that each device has to execute at least one instruction comes into place, and we should consider that as well. So there's only one special case in here. Okay, this was the general idea of problem D. For problem E, guys, if you joined just now, I'm just first saying a summary, and then from the beginning I start to explain all the problems in detail. So for now it's just a summary. For this problem I use dp. Well, we know that h of I is at most 10 to the power of 3, and the sum of them is at most 10 to the power of 5. So we can have some dp. If dp of I can be, if my happiness will be I, what is the minimum cost that I can have? I mean, what is the maximum money that can remain for me? Okay, so my dp is that dp of I is that if my happiness is I, or in here dp of j means if my happiness is j, then what is the maximum amount of money that I can have at that time? And if there's no way that my happiness can be j, my dp will be minus inf. At the end, the maximum j such that dp of j is greater or equal to 0 is my answer. And for problem F, let me bring that. I guess my internet connection. Okay. Problem F. For this problem, well, for this problem we need to have some sets, and whenever we want to cut from the right or from the left or from top or from the bottom, we just need to, if we have 4 sets, in each one of them, in the first one we sort everything by their x value in ascending order, in one by their y value in ascending order, in one with x value with descending order, in one with a y value in descending order. And whenever we want to cut from the right or left or up or down, we just need to iterate over our sets, and as much as we can remove elements, we will remove elements. So that's the general idea for problem F. And as you can see, my submission, you can see that I have just 4 sets, and I try to erase elements as much as I can. And that's gonna be all. And for problem G, the approach is greedy, and I use segment tree as well. So yeah, as you see in the tags, you can also see data structure and greedy. Each time I prove that it's the best to each time pick the one with the minimum value of C of I. Each time I choose one with the minimum value of C of I, and then I will just subtract that amount of money from the rest of the days. So I have a segment tree, and and if at any moment I move on all of the elements one by one, each time I pick the minimum. If I could take the minimum, I mean, if from the there to the end I have at least that much money, I will pick this one, and I will subtract this amount from the rest of the days. So this was the general ideas. Now I want to explain in detail. Okay. So, shall we start explaining in detail? Was that good? I mean, do you prefer that we do this every time? First a general explanation, and then explain problems one by one? I see. Yeah, that's completely okay. All of us started at some place, and at the beginning you are not able to solve even problem A. That happened also for me. I have a contest that I wasn't also able to solve problem A. It takes time. I recommend you to go to problem set, sort the problems, and solve them from the beginning. Okay, so, and the same for you, Bharat. Okay, so let's talk about the first problem in more detail first. Well, about the first problem, we have a 3 by 5, and our shape is 3 by 5. 3 by 5. Okay. And I have a greedy approach for this. And my greedy approach works like this. I try to put as much as 2 by 2 as possible because they have more constraints, because their 4 cells should be next to each other. And it's better if I put as much as possible first, and I put the rest of the rest of the cells one by ones. So this is a greedy approach. I try to do this as much as possible until I ran out of 2 by 2s, and then I can easily count that those 1 by 1s will take how many of the remaining shapes. So yes, yeah, okay. So the greedy algorithm works like this. I have, in here, x is my 2 by 2s, y is my 1 by 1s. First, I say that x is equal to, I say that I set my ans initially as x divided by 2. So I see that how many 2 by 2s do I have? I divide it by 2, floor of division by 2, so that I have at least that many shapes, 5 by 3 shapes, such that each of them have 2 by 2s. I can put at most 2 by 2 in a shape. So I have these many, and then I should say that x is equal to max of x minus 2 times ans. This is always greater than 0, but it is just the shape of the code. Y is equal to maximum of 0 and y minus 7 times ans, because each one of them have 7 of y's. And then if x was 1, if x was odd initially, now it is 1. Then I set x to 0, y equal to maximum of 0 and y minus 11, because I put 1 2 by 2 and 11 1 by 1s. And ans plus plus. And then the remaining ones, I have y 1 by 1s remaining. So I should compute the sale of y divided by 50. And this is sale of y divided by 50. And at the end I see how it ends. So that's how I can solve problem A. Does that work? I mean, does this make sense? Yes, y plus 14 is because I want to calculate the sale of y divided by 15. So for example, if y is, for example, 18, the sale of 18 divided by 15 is 2. It's the first integer greater than 18 divided by 15. So the point is, whenever we want to calculate the sale of A divided by B, we can simply say that it is equal to A plus B minus 1 divided by B, floor of A plus B minus 1 divided by B. Okay, and because division is by default, if you use integers, calculates the floor of them, I just add 15 minus 1 to it. I don't know. Yes, we can also use built-in sale, but I'm more comfortable with this one, because when it is not necessary to use a function, I try to not avoid using it. Yes, thank you, Asif. That's a good comment. Okay, so shall we move on to problem B? What is 0LL? 0LL is 0. Just because I have some defined int LL, everything is long in my code. Everything that was int now is LL. Okay. So now when I calculate maximum of 2 things, it gives me an error because this is a long, and if I put 0 in here, 0 is an int. 0LL is 0, just it is in long. It is saved in long. Okay. So yeah. I don't usually use that. I Yeah, in yesterday's challenge I defined int ll because many problem needed ll and it is remained from there. But usually it's not good to do that. Only in easy problems it is good because you're sure that it's not near time limit. But in harder problems, if you do that, you might get time limits. Okay. Atom. I use Atom. This software. Okay. No, I'm not friendly tourist, but I like to be. Maybe I have a interview with him soon. Who knows? Okay. Yeah, int to long, it makes your code slower. So it's better if you don't do that. If just if you're sure that you won't get a TLE, your solution is way better than the time limits, then you can use it. Okay. Yeah, Codeforces might be different and it tests on several tests. So maybe you don't know on which test you got a wrong answer. I mean, what was the inputs that you got a wrong answer. So maybe that was why you got a wrong answer. Okay, for the second problem, the only thing that matters is that, okay, everything is reversed, so we reverse them back. So if C is mapped to S, then we map S again to C. So if C is turned to S, then we again turn S back to C. So the only thing we need to do is that for the string, we save all the characters and we sort them alphabetically, and we have a unique set of all of them, and then we just find the one matched with each one and we swap them. So it's just enough to say that I see in a string S and I just push back all the characters in a vector, and then I sort the vector and I make it unique. This code, this line of code that you see in here, all it does is that first it makes vector unique, and this unique function returns the new size of the vector. I mean, it returns a pointer to the first element that is not in the vector anymore. So because when we make it unique, the size will be less than what it was previously. For example, unique means that if, for example, your array is this S, F, if your vector is this S, F, C, S, S, C, it turns into S, F, C, for example. Let me first sort it. First we sort it, it becomes C, S, S, sorry, C, C, S, 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 F. And then when we want to make it unique, it becomes C, S, F. So we remove the duplicate elements, and the rest of them will be some weird numbers, for example, some question marks or something. This unique function returns a pointer to here, and when I subtract vector begin from it, I find the distance between the begin of the vector and this, which is, for example, 3 in this case, and that is gonna be the new size of my vector. So I say vector to resize this much. So this part is just for sorts the vector and make it unique. It's just for compressing everything. And then I have a 4 from 0 to size of S, and I just say that id is equal to lower bound of vector to begin vector and S of I. And then I say that S of I now turns into vec of size of vec minus 1 minus id. It's exactly the mirrored elements of the vector. Okay. Yeah, that also works. So that's all. That's all. We just have and we just save all the characters, we sort them, unique them, and then we try to match them and just turn back everything that is changed. Okay. Yeah, we can also use map, but it is preferred to avoid using map. Yeah, for comparison, map can also be used, but it's better if we do it with this approach. It's both faster and it doesn't need an additional map. Map is not the best choice mostly. Oh, okay, sorry for that. This is s dot size. This is nothing. This is s dot size. And it's just in my code. Define s set of x size. So don't worry about it. Just we have a for to s dot size. Okay, so shall we move to the next one? Problem C that many of you said that you stuck in it. Well, for problem C, Polycarp was given an array A of n integers. He really liked triples of numbers. Okay, so the problem states that we have an array A of n integers. We want to count that how many for each 3 consecutive elements. If we consider every triples, triple means 3 consecutive elements. How many pairs do we have that differ in exactly one of the digits, in one of the numbers, one of the elements? So we want to count between each pair of triples, how many pairs do we have that they differ only in one element. Well, I used map for it. How? I just save that. For example, consider this case. What are our triples here? Our triples are 3, 2, 2, 2, 2, 2, and 2, 2, 3. Right? These are our triples. Right? I just have 4 maps. In one map, I save that how many of each triple I have. So for example, for 3, 2, 2, it is 1. For 2, 2, 2, it is 1. For 2, 2, 3, is also 1. In another one, I save the first 2. So for example, let me show it on this triple. I have a map that saves the triples, so I should say that. I call it gen. It's a general map that saves everything. In this one, I should say that 3, 2, 2, because I used pair of ints and PII, I just write it like this. Plus plus. In this one, I have another map that in which the last element is question mark, but for the first 2 elements we know which are them. So I say mp1 of 3 and 2 plus plus. It means that the first 2 elements of triple is 3 and 2. The last one is a question mark. We don't know what it is. Okay. The third one, it is not a vector. It is a pair. You can just use these brackets to show a pair. I'll show you this in code. This is just a pair. These are just pairs. And this is a pair of int and pair of int and int. And in here we have mp2 of, mp2 has the first and the last element and the middle one is question mark. So again we have 3 and 2 and the middle one is question mark. We say plus plus. And mp3 has the last 2 elements of a tuple, of a triple. We have 2 and 2. And we say plus plus. So we save all these, and in order to count the answer, we just also need that when we encounter a triple, we just can find that what is the answer. Let me use, for example, this color. What is the for example, MP1 of 3 and 2 means all the triples that they also their first element was 3 and 2. And subtract this gen of 3 and 2 and 2 from it. Because it means that their first elements were 3 and 2, but their last element was not 2. Because otherwise they were calculated in here as well. So I should add MP1 of this minus gen of this. Also, I should add MP2 of this minus gen of this, because it is all the triples that their first element is 3, their last element is 2, and the middle one is a question mark, and I'm subtracting all of them that the middle one is also 2. And this is MP3 of 2 and 2. That means that all the triples that their last two elements are 2, and the first one is a question mark, we're not sure about it. And if we subtract gen from it, this will also gives us some answers. So we just update these maps and calculate the answers like this. Right? So we just can now see my code. Well, this is all I'm doing. I have a map from PII to int. I have 3 maps from PII to int, MP1, MP2, and MP3, and I have a map of pair of ints and pair of ints and ints. Each name is gen. Okay, and I do exactly the same thing I said. Whenever I got a triple, first I say that I say that val is equal to gen of AI plus 1, AI plus 2. So as you see in here, these signs show pairs. So when I put a comma between them, it's just a pair of numbers. This one is a pair of a number and a pair of numbers. So I first see that how many triples are exactly this, are exactly equal to this, right? So I can just say that first I add MP1 of AI and AI plus 1, so there are the first two elements, and I subtract val from it, because val is the number of them that they have these two, but also their third one is the same. And then also for this one, we have to add this map minus val, and we have to add this minus val, and then we update all the values, and at the end we see how it ends. Okay. So this is how we can calculate it. Does this make sense? Let me read your comments. I see. Well, because Pavon, I guess, because as it says, it is not able to hash a vector. You know, pair is just two numbers, but vector can have many numbers, etc. And as your compiler is saying that it is not able to hash a vector. It says that a vector is not hashable, and therefore, because map uses hash, you cannot have it as your first element. That's what it's saying. Okay. Right. Yeah, you can also use tuple. Why is gen stored as int and pair of int and int? Because it is 3 elements. So I saved it like this. The first one is the first element of the triple, and this is the second and the third elements. You could also use tuple as someone said in the chat. You could also use tuple, but I was just more comfortable to just use a pair of int and pair of int and int. Okay. Yeah, sure. I explain it again. I'm just saying that all I'm doing is to just, for each triple, I just save how many times that triple, I have that triple in one map in gen. So as you see, when I see AI plus 1, AI plus 2, I just say that gen of AI and AI plus 1 and AI plus 2 plus plus. It means that I saw this triple. So I save that. How many of each triple do I have? Okay. So for this MP1 means that how many triples I have so that their first element is AI, their second element is A of I plus 1, and their third element is a question mark. So the third element is not definite. Also, this is saying that how many triples do we have such that their first element is AI, their second element is a question mark, their third element is A of I plus 2. I should add that by 1 as well because I saw another such triple. And MP3 means that how many triples do I have such that the first one is a question mark, the second one is A of I plus 1, and the third one is A of I plus 2. Okay. So these are the three maps that I save. And if, yeah. So this is how I store these maps. And whenever I want to calculate answer, first I say that ans plus equal to this, AI and AI. I calculate that how many triples do I have such that their first element is A of I, their second element is A of I plus 1, and their third element is a question mark. And then I subtract val. What is val? Val is the number of triples that are exactly this. So it's like I'm subtracting all of the triples such that their first one is AI, their second one is AI plus 1, and their third one is A of I plus 2. Because they are completely the same, so I should subtract them. I want the third one to be different, so I should subtract this. And I should do the same thing for this second element and for this third element. And this way I can update my answer. Okay, awesome. So, yes. Gen is designed to hold that for each triple, how many times it appeared in our string, in our array. Okay. And this minus val, as I said, is that because in here I know the third one is a question mark, but I don't want it to be A of I plus 2. I want it to be anything other than A of I plus 2. So I subtract val from it. Yeah. Can you explain why this is faster than brute force solution? Well, by brute force solution, if you check each of those two triples, that would take a lot of time because n is at most 2 times 10 to the power of 5, and your algorithm will be n squared, right? Your algorithm would be n squared that way. However, our algorithm is n log because we just for each element we just do some things with map and we just update our answer. So that brute force solution is often squared, and this gonna get TLE, but this does not get a TLE. The gen is a map, and it says that how many triples do we have such that their first element is AI, their second element is A of I plus 1, their third element is A of I plus 2. So it just saves that how many triples do we have with these elements. Okay. The best way is to calculate it in the loop, because you want, whenever you see a triple, you want to see that how many of the previous triples were a good match with it. Okay, so in the second one, you calculate that how many of the others could come after this and they are the same. So this way you calculate each pair exactly once. Okay, the reason that I update ans inside the loop is that I want that whenever I reach a triple, I see that how many of the previous triples were good with it, so that I calculate each pair exactly once, it in its second one. Okay. The result of the yesterday duel was not good at all, and we definitely will have a rematch. Yeah. So, shall we move on to the next problem, or do we need more explanation on this one? The time complexity is O of n log n, since each time we work with maps, and map takes log of n. Okay, sure. So let's move on to the next problem now. Okay, in this problem, assume that we have two robots. I use robots. I talk about robots in this problem. We have two robots and we want both of them to be at the same position at the end, right? So I'm saying that just do it with one. Assume that only one robot does all this. So first it goes north, then east, then north, then south, then north again, and then east. So it starts at 0 and 0 definitely, and ends at 2 and 2. I'm saying that if after all both of these coordinates were not even numbers, the answer is definitely no. Because if I have two robots instead of one, and the first one is gonna end up at points x1 and y1, the second one will end up at points x2 and y2. The first one end up at x1 and y1, the second one end up at x2 and y2. x1 plus x2 should be equal to this, y1 plus y2 should be equal to this. Okay. So I'm just saying that if we do this only with the about unordered map, okay, I talk about that at the end of this stream, sure. So I'm just saying that if we do it only with one robot, at the end both of the coordinates should be even. Why? Because at the end we want x1 to be equal to x2 and y1 equal to y2, and the sum of these two should be equal to this, and the sum of these two should be equal to this. So both of them should be even numbers if x1 and x2 are equal and y1 and y2 are equal, because this should be equal to 2 times x1, this should be equal to 2 times y. Okay, does this make sense? So the first condition is that one of these numbers was odd, then the answer is definitely no. Because definitely the parity of those xi's, for example, if x, the sum of them, for example, in the x coordinates, but for example at 3, the sum of these two should be 3. Because each action, when we move north or when we move south, each of them relates to one of the robots. So it has effect on x1 plus x2. So if in total, if we add them up, this will be an odd number. It means that for sure the parity of these two cannot be equal. Therefore, these two numbers cannot be equal at all. Okay. Does this make sense? If you're okay with that, put a plus, otherwise put a minus. If you need more explanation, I can say. Well, at the moment, no, unfortunately, because I think I need to explain the problems first. Okay, sure. I'm just saying that each of these moves is for one of the robots. We have two robots, Each of these moves is for one of the robots. When we have a north movement, either we assign it to the first robot or we assign it to the second robot. So we assign it to exactly one robot. So it's the sum of x1 plus x2 will be added by 1 after this move. Because one of them does not change, the other one will be added by 1. So assume that x is equal to sum of x1 and x2, the positions of the robots. And y is equal to y1 plus y2. I'm just saying that each time when we have a north, x1 plus x2 increases. If we have south, again we will assign it to one of the robots. So x1 plus x2 decreases. If we have east, y1 plus y2 increases. So this big Y increases. If we go west, y1 plus y2 decreases. So this capital Y decreases. So that's all. It's fine now. So I'm just saying that if I want to calculate x1 plus x2 and y1 plus y2, then I can easily update them because any movement will be assigned to one of the robots and it will add or subtract exactly one from one of them. So now I'm saying that these numbers should be even. Why they should be even? Because I want x1 and x2 to be equal. So x1 plus x2 should be equal to 2 times x1 and should be equal to 2 times x2. Okay, so they should be even. X and y should be both even. And y1 plus y2 is definitely equal to 2 times y1, and also I can say that it is equal to 2 times y2. So these two numbers are even. So if they're odd, then definitely the answer is no. For example, in this case, it is odd. Because we have west 3 times, so x, the capital X will be 0 at the end, capital Y will be minus 3 at the end. And this is an odd number, so the answer is definitely 0. The answer is definitely no. Okay, for the second case. Otherwise, if we forget about this condition for a second, we have a condition that each device must execute at least one instruction. So both of them should move at least once. Let's forget about this condition for a second. Let's forget what it was. And let's solve the problem without this condition. Assume that they can have no moves at all, no instructions at all. First, do you agree that at the end, when I calculated x and y, both of them, x1 should be equal to capital X half. x2 also should be equal to capital X half. y1 should be equal to capital Y half. And y2 should be equal to capital Y half. So it's like now we know that where exactly these two robots should go. And definitely, if we only move one robot to this point, if we only care about robot 1, and we only try to move robot 1 or device 1 to point x1 and y1, then automatically the other robots will also go to this point. If we only care about robot 1, if we only care about device 1, and we try to move it to point x1 and y1, then the other robots, the other device, will definitely go at the same place. Why? Because I know that sum of x1 plus x2 is capital X. So if x1 is x half, then x2 is also x half, because x1 plus x2 is equal to x. Also, I know that y1 plus y2 is equal to y. So if y1 is equal to y half, then definitely y2 is y half as well. How come x1 is equal to x half? Because I said that x1 plus x2 is equal to capital X, right? Capital X is the sum of x1 plus x2. That was the definition of it. Okay. Capital X is equal to x1 plus x2. I explain it again. Capital X was x1 plus x2. Capital Y was y1 plus y2. Okay. And I'm just saying that these two numbers should be, if x1 is equal to x2 and y1 is equal to y2, both of them should be, I mean, x1 and x2, both of them should be x half, capital X half. y1 and y2, both of them should be capital Y half. Right? Do you agree with this? And then I say that, okay, so these numbers definitely should be even. They cannot be odd. Because these points should be integer. And now, the next fact that I'm saying is this. It is only enough to move device 1 to point x1 and y1. It's just enough to move points, robots 1, device 1 to points x1 and y1. That is enough. Okay. So why? Because I know that x1 plus x2 is equal to capital X and y1 plus y2 is equal to capital Y. So if x1 is equal to capital X half, then x2 will automatically be equal to capital X half. If y1 is equal to capital Y half, then y2 is definitely capital Y half. Okay, I guess the explanation is not clear. Can you tell me that which parts does not make sense? I mean, if there's any problem in any part, feel free to say it. So capital X was x1 plus x2. Capital Y was y1 plus y2. And I'm just saying that at the end, if x1 is equal to x2 and y1 is equal to y2, x1 should be equal to capital X half, x2 should be equal to capital X half, y1 should be equal to capital Y and half, y2 should be equal to capital Y half. Okay. So they should be equal. So x1 should be equal to capital X half. So capital X itself should be even. So the first fact that we said is that these two values are both even. The second fact was that it is only enough to move device number 1 to this point. If we only move device number 1 to this point, I'm arguing that the second device will also go to this point automatically. Why? What is the reason of that? What was capital X? Capital X was sum of x1 and x2. So capital X was sum of x1 and x2, right? So if x1 is equal to capital X half, then x2 is definitely capital X half as well, because the sum of x1 and x2 is equal to capital X. It's the definition. So x2, by this definition, we can say that x2 is obviously equal to x minus x1. So if x1 is, we don't need to worry about both of them. If only x1 is equal to a capital X half, then x2 will also be equal to capital X half. If y1 is equal to capital Y half, then y2 is also equal to capital Y half. So it's only enough to move one device to this point. If at the end one device is at this point, then the other device will definitely be at the same point, because we know that the sum of x's are fixed and the sum of y's are fixed as well. So when we know the location of one device, the location of the other device will be uniquely determined. So if one of the devices is in the correct position, the other one is definitely in a correct position as well. So that's all I'm saying. So I should just take care of the fact that this device, the device number 1, should go to this point. And then I don't worry about the second device. Second device will definitely be there as well if device 1 is there. Okay, is this part now clear? You can use plus in the chats if it is clear. Or you can use this 100 reaction. Okay, awesome. Awesome. So yeah, this is it. And now we just need to be worried about moving one device to its position. And I said that for a second, let's forget about that each device must execute at least one instruction. I will tell you how to deal with it at the end. But for now, let's forget about it and solve it without that. Okay, so if we want to solve it without that, it is just enough to say, let me first explain a little bit more. It is just enough to say that if this device, as I said, we only care about device number 1. Each movement, if it was making this device closer to its goal, we will take that move. Otherwise, we will not take that move. So for example, if device number 1 is here and the goal, the destination is in here, if we had a move in this direction or this direction, we will take that, we will go to that direction. Otherwise, if the moves were in this direction and this direction, we will not take them, we will not go through them. So we take any move that makes us closer to here. And this way, if we only take those moves, I mean, for example, if the destination is at point x1 and y1, then definitely, for example, in this case, it is in northeast. So we have x1 north moves and y1 east moves. And we definitely have them because we know that capital X is 2 times x1 and capital Y is equal to 2 times y1. So we had at least twice of these north and easts because the sum of everything was somewhere here, x and y, capital X and capital Y. So we had at least capital X norths and capital Y easts. We had at least this much, which is greater than x1 and y1. So we need this much. All we are doing is to take x1 north moves and y1 east moves. That's all. Yes, exactly. I imagine a general problem of this problem that all devices must take at least one move. Well, that would be harder if we have k devices. Maybe we can think about that. But no, that way, if we have k devices, we need to make sure about k minus 1 devices so that we know that the last one is fine as well. Because we are sure about the sum of them. If there are k robots, we need to be sure about k minus 1 robots. And that's why for 2 it is good, because we only can care about 1 robot. And yes, exactly what Shayan has said is completely correct. So whenever it was making us closer to there, we were taking it. It means that this was in the correct direction. We will taking it, otherwise we will not take it. And this way we are sure that we will be at our destination. And the other robot will take the rest of the movements, and that one will also be in the correct position, because we proved that if one of them is in the correct position, the other one is in the correct position as well. Okay, still we haven't talked about these parts, but don't worry about this. Let's not worry about this. We will talk about it, and that's not hard to answer. That is just a single if in here. That's just a very special case. So all I do is that I calculate x and y, as you can see in here. This is capital X. I mean, this is equal to what I was explaining for capital X. This is equal to what I was calculating for capital Y. So it is the sum of all these values, and dx and dy are defined here. The dx of north is 1, dy of north is 0. It means that it adds 1 to x value, north adds 1 to x value and none to y value. S adds -1 to x value and none to y value. E adds 0 to x, 1 to y, W adds 0 to s, x, and -1 to y. So I calculate the sum of these, and then at the end I divide them by 2. Now our destination is x and y. Because as I said, now x is equal to that capital X divided by 2. And now I will explain this part as well in a second. But for now, let's just talk about this. I'm just saying that I have a 4, and I'm just saying that if ABS of x minus dx of s of I was less than ABS of x or this, it means that if at least in one direction it was making us closer to our goal, just take it for the robot number 1, which is our rover, and this one is helicopter. So take it, and x would be and you have to remove it from x. I mean, our x is now our distance to our destination, right? So we can remove it from x. So there are remaining things. There are less remaining things. Otherwise, we have it for the hover. Okay, so that's the general idea. That's a greedy algorithm. If it was making us closer, then do this. Now, when we want to deal with the fact that each robot should have at least one instruction, first, there's a special case. If x and y were both 0, this is this special case. We have a south and a north. If only one robot could take all the moves, one robot could go to south and then to north and get back to 0 and 0. And the other robot could not move at all. And they were in the same cell, in the same points. Okay, is everything clear so far? You can use reactions or put a plus. If you have any questions so far, you can ask. I'm just explaining the last part about how to calculate, how to consider that a special case that each robot should have at least one move. Okay, awesome. So I'm just saying that if sum of these two is equal to 0 and 0, then we can say that if the number of moves is 2, the answer is definitely no. Which is these two cases. If we didn't have that that rule that each one of them should have one instruction, they were possible, because for this one we can go south and then north. For this one we could go with one robot to west and then to east, and both of them were at 0 and 0. But it is not possible, because each one of them should have one. So we have two moves in different directions, and each robot should take one. So one of them will end up here, one of them will end up here. It's not possible that both of them will end up at the same place. That is not possible. Therefore, we can be sure that in this case the answer is no. So first of all, we have to add this case, that for this case the answer is no, definitely. Okay. And there's another thing, that it is possible that x and y are both 0. X is 0 and y is also 0. And one of the robots do not move. For example, in this case, we have 4 S, S, N, N. Only in the case that x and y are both 0, it is possible that one robot does not move. Because otherwise, both of them should end up in a different place. So both of them should move. But if x and y is 0 and n is greater than 2, I mean the number of moves is greater than 2, the fact is that we do not move the helicopter at all. We do not move the rover, I mean. We do not move the first robot at all. Because we see that it is at 0 and 0, and that's fine. But that's not correct, because we have to move it at least once. That's why you saw in my code that initially I forced the first robot, to do the first move. then it is not in 0 and 0 anymore. And even if the final goal is 0 and 0, it needs to have one more action to get there. So this say I'm sure that this robot will also move. So these two parts is only for the fact that both of the robots should have at least one move. This is because in this case there is no answer. This is because if x and y are both 0, there's a case that this robot will not move at all. So I always force the robot to do the first move. And this way I'll be sure that it will move. And it will still have a chance to get to the destination. Because again, I'm sure that wherever the destination is, I have twice of moves to that direction. So even though if I moved to a wrong direction, I have the chance to get back to there if there is a positive goal somewhere. So everything is gonna be fine. Does this make sense? Was it hard? Was this solution hard? I suppose that this is not very hard. So the fact is that there were just some facts. The only fact was that we calculate the sum of them and we know that the goal is the half of that point. And then if we move one robot there, we're done. And then we just do that. And this last part of explanation was just for this sentence. That we just need at least, each of them should execute at least one of them. The key observation for this question is that the sum of these two numbers, I mean x1 and x2, if we add everything, every move, and we see where do we end up, the key observation is that both of the robots, if we just add up everything in here, it points out some points in our grid, x and y. The key observation is that both of the robots should go to x half and y half. That's the key observation. And the next key observation is that if we move one of the robots there, the other one will go there automatically. So this is the most important thing that we should do. Right. So is it clear? DP, I'm not sure if you can use DP on this one. Yeah, thank you. Okay, so shall we move on to the next one? About DP, I'm not sure that's how can you solve it with DP, but I guess this problem doesn't have a solution with DP. And let me just double check with the tag. Yeah, as you can see here, no, it seems like nobody has solved with DP. So, problem E. Money buys happiness. Being a being a physicist, Charlie likes to plan his life in simple and precise terms. For the next M months, starting with no money, Charlie will work hard and earn X pounds per month. For the ith month, there will be a single opportunity of paying cost CI pounds to obtain happiness H of I. Borrowing is not allowed. Money earned in the ith month can only be spent in a later jth month. Since physicists don't code, help Charlie find the maximum obtainable sum of happiness. Well, in this problem, as I mentioned, I use DP. I can say that for, initially I started to think about it a little bit. I wasn't seeing the constraints precisely until I saw this line that sum of HI's is bounded. It is at most 10 to the 5th. And this is a very important fact. When we know that sum of h of I is bounded and h of I itself is bounded as well, we can say that, okay, we can have a dp of size at most 10 to the fifth, or m times h, which is 5 times 10 to the fourth. They are not very different, so I take 10 to the fifth. dp of I can be that what is the maximum money I can have if my happiness is exactly equal to I. Okay, so dp of I is the maximum money that I can have if my happiness is equal to I. And if there is no way that my happiness is equal to I set dp of I equal to minus inf. I set it to a large negative number so that I make sure it is less than 0, and it means that it is just not possible. Okay. So if I define this dp can be easily calculated, because each month when we are trying to transit from some month to the other one, for example, we are at month number I, and we are thinking about dp of j. We want to see the transitions from dp of j. The first possible thing is to just do nothing, buy nothing. Then our money will be added by x, and we will go to dp of j again. So first I have to add x to dp of j, because if this is for the case that we don't buy anything. So we have dp of j, we just add it by x. Okay. So the next one, oh shit, sorry for that. So the first case, let me use whiteboards. So the first case is this. We have dp of j, and there are two cases. Whether I don't do anything, I don't buy anything, so my money just rises by x. So I go to, let's call it dp prime. dp prime is the dp's that we have after this round. Let's call this one dp prime, this one dp second. Okay, so dp prime of j is that our dp after this, before this month, this is dp prime of j, and if we don't buy anything, the money will be just rise by x. And if we buy something, we have a condition first. First, this dp should be greater than or equal to the cost of buying happiness here. And if it was so, our money will be added by x minus c of I, which can be a positive or a negative number. But this is gonna be, the final answer is gonna be greater than 0, because we know that dp prime of j is greater than or equal to c of I. So when I subtract c of I, it is at least 0, and then x will be added to it. So first, maybe it's better if I write it like this. First, it will be subtracted by c of I, and then it will be added by x. Okay. So all I'm saying is that if this happens, I will go to dp second of j plus hi, because now my happiness will be increased by hi, and my money will be subtracted by ci and added by x afterwards. So this is my transition. This is the transition I'm gonna have. Okay, dp of j, as I said, dp of j means that what is the maximum possible money that I can have if my happiness is gonna be equal to j. Okay. Yes, this is a one-dimension dp. And these signs that I show here, they are the same dp. These signs is just in order to show you that what is my dp before this round and after this round. But they are the same, repeat. This is before this round, this is after this round, after this month. So if we do nothing, the same dp will be added by x. If we buy happiness, we have this condition, only in this condition we can buy happiness. And then our money will be subtracted by c of I and increased by x, and then we will go to dp of j plus h of I. Yes, dp of j is our state. dp of j means that our happiness, dp of j means that our happiness is exactly j. Okay, our happiness is exactly j. So dp of j means that our happiness is exactly j. What is the maximum amount of money if our happiness is currently j? And if there is no way that our happiness can be j, we set the answer of dp of j to be minus inf. Okay. Okay. So dp of j, the state of my dp is just some value j. It means that my happiness is equal to j. My happiness is equal to j, and I'm just saying that if my happiness is gonna be j, then what is the maximum possible value that I can have for my money? Okay, does this make sense now? I mean, maybe you can use reaction or something to see that how's, so that I can see how is everything going. Yeah, sure. So all I'm saying, okay, let me close some of this. Sorry for that. So all I'm saying is that for each of these cases, dp of j is a very simple thing. It's nothing special. dp of j means that, okay, assume that my happiness is gonna be j. Okay, dp of j means that my happiness is gonna be j. What is the maximum money that I can have? So I fix the amount of happiness and I try to find out what is the maximum money that I can have with this happiness. Okay, that is all I'm gonna do. For example, let's take a look at an example. We have in here 1, 10, m is 1, x is 10, and 1 month. We cannot buy anything. So this, let's consider the second one. We have 2, 80, 0, 10, 20, 200, 100. The first line is okay. This one is also not a good example. I mean, the examples are not very good. So in the third one, let's consider the third one. In the third one, in the first month, we have 70 and 100. We cannot buy it, definitely. We have no money. In the next one, we have 100 money. So dp of 200, our happiness might become 200. If our happiness becomes 200, our remaining money will be 100, right? Because we have 200 amount of money and we are gonna spend 100 of that. So dp of 200 becomes 100 and dp of 0 will become 200. Because if our happiness is 0, we are able to save 200 pounds. If our happiness is 200, we are able to solve 100 pounds. And then the day after that, we have 150 and 150. So from this dp, we cannot buy this. So only dp of 200 will become 200 because we add x to it. We add the money to it. dp of 0 also become 300. But also in this case we can buy this happiness, so dp of 150 will become 200 minus 150, which is 50, plus this x, which is 100, so will be 150. And dp of 0, as I said, will become 300. So it's just saying that if at the end my happiness is 200, the maximum amount of money I can have is 200. If my happiness is 0, the maximum amount of money I can have is 300. If my happiness is 150, the maximum amount of money I can have is 150. Does it make sense? For every happiness, yes. Yes, exactly. For every month, for every month I will try to update all the DPs. That's all I'm doing. Okay, does it make sense now? I will tell you about time complexity and what exactly I'm doing. So are you just storing the max index you encounter? Yes. At the end, my answer is going to be the maximum DP such that its value is greater than 0, greater than or equal to 0. Initially, all the DPs are minus inf, because initially we cannot reach any happiness greater than 0. Initially, DP of 0 is 0, and DP of all the happinesses greater than 0 is minus inf, because it is not really possible to have them, right? So that's all. So at the end, it will be the maximum DP greater than 0. So how do I calculate it? How do I calculate the DP? I mean, how do I implement it? Well, the point is that each time, first of all, this is my DP. I just have it in a vector. I just at that moment felt like it is easier for me to implement it like this. I had DP. First, it has only 1 0, and then whenever I get some HI, I have a 4 of size HI, and I push back minus inf to it. Okay, because it means that these next DPs are minus inf. The value of these next DPs is minus inf. Yes, exactly, Abhinav, exactly. And then I have a 4 from 0 to m, the number of months. It is at most 50. Then I have a 4 of j from size of DP minus 1 going through 0. And then first I say that DP of j plus equal to x, and also if j was greater than or equal to hi. And DP of j minus hi was greater than or equal to ci. What does it mean? It means that if j definitely should be greater than or equal to this happiness, we are considering the case that we bought this happiness. So if we bought this happiness, then definitely our happiness should be greater than or equal to h of I. And also, dp of j minus h of I should be greater than or equal to ci. It means that I should have at least ci money in my dp of j minus h of I. If my happiness was j minus h of I and I was able to save at least c of I pounds. In this case, I can say that dp of j is equal to maximum of dp of j and dp of j minus hi minus ci, which is the cost of buying this happiness, plus x, which is my monthly salary. So this way I can update my DPs. And the reason that I start from the end and go through the beginning is that because I want this dp of j minus h of I to be updated after I update dp of j. If I go from the end, I know that j minus h of I is less than j. So I know that it is not updated yet. So it has stored the value before this month. And that's exactly what I want. I want to see that before this month, what was the maximum money that it could possibly save. Right? So that's gonna be all. J is happiness, yes. J is happiness, dp of j is current money, not current cost. J is happiness, dp of j is the current money that we've saved. We try to maximize dp of j. And if we can save some positive, some non-negative amount of money at some point, it means that it is possible to have that. I'm just saying that, it is just saying this. And I mean, there's nothing complicated in here. That's exactly the same thing I did on this example. Not here. That's the exact same thing that I did on this example. You saw that when 70 and 100 came, nothing was updated. When 100 and 200 came, the only thing I was doing was to update dp of 200. dp of 200 was updated by dp of 0, and the cost was 100. So I said that this is equal to dp of 0 plus minus this 100 plus this 100. So I just say that I have a 4 from the end and go back to 0, and I say that dp of j initially plus equal to x. This is the case that I don't buy anything. I don't buy anything. This is that case. This case is if I buy anything. I buy this. In this month, I will buy happiness. In this case, definitely my happiness should be greater than or equal to hi. Because if I have bought happiness, then definitely before this step, my happiness was at least 0. So dp j minus h of I should be a positive number or non-negative number. Because if I bought this happiness, then I should have at least this much happiness. If I bought this happiness, if j was greater than or equal to h of I, and dp of j minus h of I, which is the maximum possible money that I could have if my happiness was j minus h of I. If that money was greater than or equal to c of I just say that dp of j is equal to maximum of dp of j and dp of j minus h of I minus c of I plus x. Does this make sense? Again, if you want, you can use reactions or put a plus. Yes, definitely. I will share more DP problems in our Discord server, and I will try to start solving them and record myself solving them as well. Sure. These are some sort of knapsack related problems. They are very similar to knapsack. You don't have Discord link? Can someone please send the Discord link here? Let me test if this one works. Okay, it works. Let me send you this. Let me. This is the link of the Discord link, the Discord server, guys. There are around 1,300 people there already, and we discuss about competitive programming, and I can share problems there. People who I interview with join this server. Yeah, and I want to increase its activity in the future, but yeah, right now it is like this. Okay, shall we move on to the next problem, or do you have any more questions about this one? Unable to accept invites. Do the rest of you have the same issue? Does anyone else have the same issue? Has anyone been able to join the group using this link? Okay, worked. Okay, good, good. So yeah, so no questions about this one. Can we do it with recursion? No, with recursion, diffie is very similar to recursion, only it saves the values. If you do recursion, then your algorithm will be exponential, and you will get time limits. So you can. Okay. So if there are no questions about this one, yes, you have to memorize it if you do recursion, which is very similar to deep. Okay, the next problem. Alice and Bob were playing a game again. They have a grid of size A by B on which there are n chips with at most one chip in each cell. The cell at the intersection of the xth row and the yth column has coordinates x and y. Each time each player will choose one of these directions, u, d, l, and r, and an integer k. If the character is u, then the first k remaining rows will be cut. If it is d, then the last k remaining rows will be cut, and so on. If it is l, the leftmost columns, if it is r, the rightmost columns will be cut. So based on the initial state of the grid and players' moves determine the number of points earned by Alice and Bob respectively. Okay, so in this problem, as I said, we can use a set, and each time, for example, assume that we want to remove something from the right side. As much as we can, we remove it from our sets. So we have 4 sets. In one of them, we sort everything by x. In one of them, we sort everything in ascending order. In another set, we sort everything by x in descending order. Also, we have a set that we have 2 other sets that we store everything, we sort everything by y in ascending and descending order. Each of these directions will work with the extreme points of some of these sets. So in one of the sets, we can keep picking out the beginning of the sets, and then we try to remove them and update the scores. That's all we need to do in this problem. So we just save all the points. This was implementing, it was harder than explaining it. The explanation is quite straightforward. We just save, for example, in SDU, I save by the value of xi in ascending order. In SCD, I save by xi in descending order. This minus is because if some value is greater than the other one, then the minus of it is less than the minus of the other one. So if I sort them by minus of them, they will be in descending order. STL is sorted by y, STR is sorted by minus y, and I have this answer of 2 for Alice and Bob, and each time I save the 2 bounds on my grid, each time one of these pointers move. So each time, whenever I get a direction, I just move that bound, and I just need to find out, as long as I have an element that lies outside of this bound, I will erase it, I will keep erasing it and update the answers for Alice and Bob, and at the end I will see out answer of 0 and answer of 1. So the solution is quite straightforward, but mostly I can say that the implementation was a little bit of an issue in here. Does this make sense? Yeah, you could also use that. Yeah, that's a very good point. That's a very good point. We could also do that, and we could just have 2 sets and just use end or r begin to just access the last one. That could also work. Yeah. So any other questions? If there are no questions on this one, we can move on to the last problem, problem G. Maybe you can show me some reactions if you understood it again. Show the reaction so that I'll move on the next problem. Let me also pin the Discord server link. Okay, so let's move on to problem G then. Problem G is the same as problem E. The only difference is that in this one, the happiness is always 1, but the number of months is too large, is at most 2 times 10 to the 5th. So in this one, the number of months is 2 times 10 to the 5th, but the happiness is exactly 1. And the value of X, monthly salary, and C of I's are at most 10 to the power of 3. Well, in this problem, the first thing that I prove is this. Well, it seems like the fact that C of I is at most 3 to the power of 3, 3 to the third, can be useful, but it wasn't very useful in this problem. In this problem, I just use a greedy approach. I just say that I can source the values of CI's, I can source them all, and start from the beginning. And if I can pick them, I will pick them greedily. So my approach is greedy. I will sort CI's and start from the beginning each time. If I can pick one, I will pick it. If I have enough money in that moment and in the following months, then I will pick that one. Otherwise, I won't pick that one. So my condition is that initially I save the money that I can have at each month. So the first month is 0. The second month is X. The third month is 2X. 3X to the month, for example, number M is M minus 1 times X. So this is the money that I have on each day. Now, when I sort C of I's, first, I should see that after this C of I always have this enough money for it. I always have at least C of I. After this month number, I should always have this money. Otherwise, if I buy this here, there will be a point that my money will become negative. So I cannot buy it. So there are 2 things I need to do. The first one is to prove that it is correct if each time I pick the minimum CI and buy that happiness. And the second one is to how to perform these actions, how to find out the minimum in a suffix. And then if I wanted to buy, I should subtract C of I from all of them. If I want to buy this, I have to subtract C of I from all of these elements. Okay. For the second part, I will use segmentary. But what about the first part? How do I prove it? I talk about both of the parts in detail. I want to prove that it's always better to sort C of I's and try to pick them one by one. How do I say that? Well, I can say that assume that you do not do this. So you are going and on this, consider the first time, the first index. So you have a greedy approach, you have a greedy algorithm, and you have an optimal algorithm. And they are different. Consider the first index in the sorted array, in the sorted costs. The first index that they are different, greedy and optimal are different. So in greedy you pick that, and in optimal you do not pick that. Obviously that is like that, because greedy each time tries to pick that if possible. So if it is possible, greedy will pick that. So it's the optimal who should miss this one and get another one. There are 2 possibilities. Well, optimal has ignored this one in order to get another one for sure. So there is one other index, C of J, at least one other index that buys that happiness, but greedy does not buy that happiness. Okay, there should be at least one. There are 2 cases, whether C of J is to the left of C of I. If it is to the left, we know that greedy does not have that, and optimal has that, because this is the definition of this. Because we know that optimal is better than greedy, we said that if greedy has C of I and optimal does not have C of I, then optimal should have some C of J and greedy does not have C of J, right? So I will see this C of j, if it is to the left of C of I, or j is less than I. If j was less than I, let me write just j in here as the index, then I can say that I could easily remove this from opt and add this one instead, because I costs less than j, and also I have to pay this later, so it's even better. So I have to pay less money, and there is less conditions. I mean, I have to pay this money later. I have the chance to pay it later, so I can just save the money in here and just spend less money in here. I still have that money if I remove C of j. So if C of j is to the left, I could easily remove that j and have I instead. If j was to the right, again, I can say that consider the first j to the right of it. Consider the first j. I know that in between everything is the same. Okay, there's nothing that optimal has and greedy does not have. So I know that I have removed I and I have added j. And I know that nothing has changed in here for optimal. Nothing is better in here for optimal. And I know that after this I have less money compared to when I was running greedy. So again, I can say that nothing is better. So in conclusion, I'm just saying that I can have a greedy approach, each time take the minimum one, minimum C of I, and reports that as our, if we can pick that, we will pick that one. Okay. And I will move on. And each time, is this part clear? Are there any questions about these parts? If it is clear, again, maybe react. If it is not clear, just tell me that it is not clear. What do you mean by how does greedy work here? If you mean the proof, I was explaining the proof. But if you mean that how can we implement it, then I will talk about that. So the proof is that if greedy doesn't pick something and opt does not pick something and picks something else instead, I showed that in both cases, if j is to the left of I or to the right of I, in both of the cases nothing becomes better. So in general, I'm just saying that if I pick I, if greedy does something and opt does something else, I'm showing that what opt does is not necessarily better than greedy, and that's a contradiction. So opt cannot be better than greedy, so greedy works in here. So now I want to implement greedy. How do I do that? Well, it's just enough to say that for each of the elements, for each of the values, as I said, for example, I have cost ci in here. All the elements after this, at all the moments after this, my money should be at least C of I, because otherwise, if I buy this, I have an online data structure that saves that at each moment I have how much money do I have. Initially I have 0 in here, x in here, 2x in here, and m minus 1 times x in here. I end up with the same structure. Yes. If I do greedy, I can transfer optimal to greedy to have the same answer. So therefore greedy is optimal. Yeah, so this is my money initially. I want a data structure so that I can update my money at any moment in an online fashion. So I'm just saying that for each of these elements, when it arrives, I should calculate the minimum possible money that I have after this moment. If that was greater than or equal to C of I, because I have to subtract C of I from all of them, and none of them should become negative. So C of I should be greater than or equal to I mean that should be greater than or equal to c of I so that it does not become negative. If that was, then I say ans plus plus, and I will subtract c of I from all of this, and that's going to be all. So I use a segment tree. In a segment tree, I have two operations. In this segment tree, if you're not familiar with segment tree, guys, it's the best to forget about this problem for now. And after you learn segment tree, you can get back to this one and solve this one. So for now, if you're not confident with segment tree, you can forget about it. You need to know segment tree to be able to solve this problem. So all I'm saying is that if in this period, in this suffix, we have at least one element, I mean we have at least one element less than c of I, it is not possible to pick this one. So I have to calculate the minimum. This is some sort of classic segment tree problem. I can just save two values for each node of segment tree, mn and val, and seg of v dot mn is equal to minimum of seg of lc dot mn and seg of rc dot mn plus seg of v dot val. I can easily update all these values and calculate the minimum of a suffix. I can also show you my code and show you how I did this. Well, as you can see in here, I initially build my segment tree. How do I do that? I say that seg of v dot val is equal to seg of v dot mn equal to x times s for a leaf node. For a leaf node, I do this. I know that it is after months number s. So I had exactly s salary. So my money is x times s at this moment. So my val and mn are both x times s. And then in here, my value will be 0. And my mn will be in the non-leaf vertices. My mn will be equal to seg of lc dot mn and seg of rc dot mn. Val is the additional value that this node has. Okay, so this node, which is not non-leaf, it does not additionally add anything. So its value is 0. And its mn is equal to mn of these two kids that it has. And in general, I should also add seg of v dot val to this minimum of these two minimums, but because I'm sure that that is 0, I haven't done that. And then in my get function, first I say that if r was less than or equal to s or e was less than or equal to l, return inf. If l was less than or equal to s and e was less than or equal to r, return seg of v dot mn. Otherwise, return minimum of this get and this get plus the additional value that this node adds, right? And in my add function, I just say that if again this interval was completely outside of the desired interval, I just return. If it was completely in that, I just add x to the val of that node and to the mn of that node, and I will return. Otherwise, I add it to the children, and I set seg of v dot mn to minimum of seg of lc dot mn and seg of rc dot mn plus seg of v dot val. And then at the end, I can just easily sort everything by the value of c of I, each time pick the minimum, and mn will be equal to get of I to m, minimum of possible money from I to m. If mn was greater than or equal to ci, I say ans plus plus, add I to m minus ci. And that's how I can find my final answer, and that is going to be my output. Does this make sense? Val is the value of the node, and mn is the minimum cost from left to right segment. Yes, mn is the minimum cost in this segment. Val is the additional value that this node might have. Because in my adds, because I have a segment tree, in a node, if this node completely lies in my interval, I don't go further down. So I just add the value of this node. This, because I can also do lazy. I can also use segment lazy, but this is easier. I don't go further down, and I just save this value in the val of this node, and whenever I wanted to go back from this node, I just add it to whatever I want. Okay. Yeah, you need to find the minimum of a segment, because you know you know that this offer is at some month, and if you buy it you have to pay CFI, and your money in all the next days, in all the next months, will be subtracted by CFI. Do you agree with that? All of them will be subtracted by CFI. So none of them should become a negative number. If one of them becomes negative, then the answer, that is not possible. It means that you ran out of money. You're not able to rent. You're not able to have loan. Okay. So the point is, if it becomes negative, then the answer is no. I mean, you cannot buy this. Otherwise, you can buy it. So you need to check the minimum of these values and compare them to the value of CI. Does this make sense now? Yeah, I'm waiting for your reacts. Awesome. If you have any question, feel free to ask. Everything is okay now? You can hear me now? Awesome, if you can hear me. Yeah, I got my my network was disconnected, and then now I'm connected to my phone, as you can see in here. Now I'm connected to my phone, and it wasn't connecting, but I don't know how far you heard me. I don't know when I got disconnected. Yeah, I was asking if you participate in LeetCode. Do you guys participate in LeetCode? If you participate, we can do that. If many of you participating in LeetCode. And also I was saying that, yeah, that solution was really good. I explained it again, but I'm not sure you received it. I was just saying that, yeah, the solution was that we just start from the beginning and we go forward. Each element, if we can pick it definitely we will buy it. Otherwise, we consider the most expensive one that we bought, and if it was more expensive than this one, we will swap these two. We will not buy. That was also a great solution that can be also implemented with a set. Yeah, and I also, yeah, thank you very much for joining. It was great to have you here again. I hope these streams and the videos will help you both in growing and getting motivation, etc. So feel free to give me any suggestions or anything. Thank you very much, guys. I guess I will see you